In one of the direct proof videos, I gave a direct proof of this statement, and it had the same domain, the real numbers. Now I'm going to prove this statement using the contrapositive. And the thing to notice here is that using the contrapositive, it's actually much easier. All right, so again, I'm going to set the stage by calling that P, calling that Q, and noting that P implies Q is equivalent to its contrapositive, which is not Q, implies not P. So if Q is X is less than 1, not Q is X is greater than or equal to 1. Now again, remember that X is less than 1. That's all these numbers over here. So if it's not the case that X is in the blue interval, X must be in the red interval. And that's why we have that there. That's why not Q is X is greater than or equal to 1. Similarly, not P is the negation of X squared less than X, which is X squared is greater than or equal to X. And so remember, we want to prove not Q implies not P. So this is our assumption. This is what we want to prove or to show. Assume that X is greater than or equal to 1. Now remember from the direct proof video where I proved the same thing, we had this issue of wanting to make sure that we don't have to flip the sign when we multiply by X. So see what I'm going to do here is I'm going to multiply both sides of this thing by X, and that's going to give me X squared is greater than or equal to X, which is what I want to prove. Now we have to be sure that we don't have to flip the sign. Now remember, we only have to flip the sign when we multiply or divide by a negative number. But this is our assumption. We assume that X is greater than or equal to 1. So that means that X is positive. So we don't have to flip the sign, and we have so X squared is greater or equal to X, which is what we wanted to prove. So we're basically done. Now you may want to throw in another line saying something like, so since the contrapositive is true, so is the original statement. And that's the proof.